Hello everyone. Today I'm going to explain about the addressing modes in 8086 microprocessor. The addressing modes, first of all, how can we define the addressing mode? Okay, the addressing mode is defined as these are the various methods or these are the various ways by which the microprocessor can get the data or by which the microprocessor can access the memory location or IO ports in order to get the data. That is the addressing modes. Okay. Now, what are the types of addressing modes in 8086? It is a classification. These are the various types. One is immediate addressing mode. Second one is register addressing mode. Third one is memory addressing mode. And fourth one is IO port addressing mode. Okay, so these are the four types. Here, the memory addressing mode is further divided into two types. It is further divided into two types, that is direct addressing mode, indirect addressing mode. Okay, and further this indirect addressing mode is further divided into five types. That is register indirect addressing mode, relative based addressing mode, relative indexed addressing mode, based indexed addressing mode, and relative based indexed addressing mode. Okay, and fourth type is IO port addressing mode. This IO port addressing mode is further divided into fixed port addressing mode, variable port addressing mode. Okay, is it clear? So addressing modes means it is the way of methods or various ways by which the microprocessor can access the data or can get the data by accessing the memory location or IO ports. Okay, by which methods it can identify the memory location or it can identify the IO ports in order to get the data or in order to store the data. So here there are four types: immediate addressing mode, register addressing mode, memory addressing mode, and IO port addressing mode. This is the first classification. This memory addressing mode is further divided into two types, that is direct addressing mode and indirect addressing mode. Okay. This indirect addressing mode is again divided into register addressing mode, relative based addressing mode, relative indexed addressing mode, based indexed addressing mode, and relative based indexed addressing mode. These are the five types in the indirect addressing method. Okay. Next, IO port addressing mode. IO port addressing mode is further divided into fixed port addressing mode and variable port addressing mode. Okay. So now let us discuss one by one addressing mode. Okay. The first one is the immediate addressing mode. Okay. Immediate addressing mode. Immediate addressing mode, how can we define it? Means in this type of instructions, in this addressing mode, in this type of addressing mode, the data is available directly in the instruction itself. Okay. The data is directly available in the instruction itself or directly specified in the instruction itself. Okay. Now, for example, one instruction move AL, 28 hexa. Move AL, 28 hexa. Okay, what does it mean? That means this this is the instruction format. Okay, move is the type of operation. It indicates the type of operation. It is one kind of data transfer instruction. Okay, here this is the source. This is the source and this is the destination. This is the source position. This is the destination position. Always between the source and destination, the comma should be mentioned. Okay. And the data is represented in hexadecimal form. Okay. So here after this instruction, what happens? The 28 hexadecimal number is transferred to AL register. Okay, the 28 hexadecimal number is transferred to AL register. So whatever the data is transferred, that data is directly available in the instruction itself. That is the immediate addressing mode. Okay. Similarly, another instruction, move AX comma 1532 hexa. What is the difference here? This is the 8-bit register. That's why the data is also 8-bit. Here, this is the 16-bit register. The data is also here 16-bit. Okay. So 16-bit, how it is called as a 16-bit? So because the 16-bit number is represented as 4 digits, 1, 2, 3, 4. That means this 1532 is can be written as 0001, like in binary form. Okay, 0101 0011 0010. This is the 16-bit representation. Okay, this is 16-bit binary or 4 digits hexadecimal number. Because it is a AX register is a 16-bit, that's why this 16-bit number is transferred. Okay, so source is 1532 hexa number. Okay, this is one immediate data. That immediate data is transferred to AX. Already in the previous video, AX, I told you, AX is combination of AH and AL. Okay, AH and AL. Okay, so here in this AL, the 32 is transferred. The 32 is transferred to AL and 15 is transferred to AH. 15 is the higher byte, 32 is the lower byte. This lower byte number is transferred to AL and higher byte number is transferred to AH. Okay, so here this is the difference. Next one is, next type of addressing mode is register addressing mode. Okay, register addressing mode. Register addressing mode means in this type of addressing mode, the data is available. Okay, the data is available in the register. Here, the data is available in the instruction itself. Here, the data is available in the register. The data is available in the register. Okay, for example, I'm writing instruction move AL comma BL. Okay, so what does it mean? That means suppose before the instruction, if AL contains 20 hexa, if BL contains, okay, BL register contains 30 hexa, for example, then after this instruction, suppose this is the before instruction, then after execution of this instruction, what happens? After execution of this instruction, what happens? The BL register contents are transferred to AL. BL register contents are transferred to AL. That means now AL register contents becomes 30 hexa. What about the BL? The BL register is contents remains the same. That means that is the, it is just like a copied. The data is copied from BL register to AL register, or simply the data is transferred from BL register to AL register. Okay, here whatever the data we are transferring, that data is specified in the register. Here the data is specified in the instruction itself. That's why it is immediate addressing mode. This is register addressing mode. Okay, so here after this, what happens? The BL register contents are transferred to AL. So AL register becomes 30 and BL remains same 30. Okay, next. Next, uh, immediate addressing mode is over. Register addressing mode is over. Next one is the memory addressing mode. Okay, memory addressing mode. Memory addressing mode in the sense what? The microprocessor has to identify the memory location. How in various ways, how can the microprocessor identifies the memory location? Okay, in that the first one is the direct 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 addressing. Okay, direct addressing. Actually, already in the memory segmentation, we have discussed like the memory location is identified by a physical address. Okay, the memory location is identified by a physical address. Physical address is nothing but segment base address. Okay, segment base address into 10 hexa plus offset or effective address. Offset or effective address. This is the physical address. Okay, but here in the instructions, we are mentioning only offset or effective address, because by default the segment base addresses are available in the segment registers. Already we have discussed in the memory segmentation. Okay, so direct addressing mode is segment base address into 10 hexa plus offset address or effective address. So in the instructions, we need to specify only effective address, not the segment base address. Okay, so now what is the example for this instruction? So move AL comma, okay, 1532 hexa. Move AL comma 1532 hexa within brackets. Okay, so when this number is represented within the brackets, within the square brackets, then it represents square brackets. Okay, square brackets represents memory location. Square brackets represents memory location address. Memory location address. Okay, so now what happens here? The 1532 is the offset address or effective address, because this is the data is transferred from memory location to AL register. So then the data segment is used for this. Okay, so for that data segment, segment base is available in the for data segment. Okay, for data segment, the segment base is available in the segment base is available. Segment base is available in the DS register, data segment register. Okay, so now assume that DS contains data segment register contains, for example, 4500 hexa. This is the segment base. Okay, now how the physical address can be calculated? Physical address can be calculated as 4500 segment base. Okay, this is segment base address star multiplied by 10 hexa plus effective address. What is the here? This is the effective address. Okay, this within the brackets we are representing effective address. Okay, so this is 1532 hexa. That means 4500 star multiplied by 10 hexa. That means this is 0 plus 1532. That means 1532. Okay. So addition. So this is 2, 3, 5, 6, 4. Okay. 46532 hexadecimal. Now it is a 5-digit number. 5-digit number in the sense it is a 20-bit. Okay, 5-digit number is nothing but it is a 20-bit. So it is a 20-bit physical address. It is a 20-bit physical address. Now what the microprocessor will do? This is the memory location. So now 46532 46532 is a 46532 is a memory location address. Now with this address, one memory location is identified. In that memory location, whatever the data is available, for example, 58 hexa is available in that memory location. That 58 number is transferred to AL register. Okay, so this is the direct addressing mode. This is the direct addressing. Once again, see, the direct addressing mode means in this, the memory location effective address is directly available in the instruction. Okay. The direct addressing mode means the memory location effective address is directly available in the instruction. So example is move AL comma 1532 hexa, which is effective address, and it is represented in the square brackets. Okay. So this square brackets represented as memory location address. Now for data segment, what happens? The segment base is available in the data segment register. Okay. Assume that the data segment register contains 4500. Then what happens? How to calculate the physical address? So 4500 segment base into 10 hexa plus the effective address 1532. With this, the physical address was calculated. Okay. So with this physical address, the microprocessor identifies one memory location. Once the memory location is identified, then whatever the data is available in that memory location, that data is transferred to AL. Okay, so that is the now after execution of this instruction, AL contains 58 hexa. Okay, that is the direct addressing mode. Okay, next register indirect addressing mode. Okay, register indirect addressing mode. Register indirect addressing. Okay, so for this type of mm, addressing mode, BX register or source index register or destination index registers, these are useful. Mainly, these registers are used. Okay, what is the purpose of this? What is the example for this instruction? Same move AL, comma, for example, BX. Okay, move AL, comma, square brackets within that BX. What is the meaning of this? First, this square brackets represents a memory location, and within that, the effective address. So here, the BX register contains, okay, the BX register contents, the BX register contents acts as a effective address. The BX register contents acts as a effective address. The BX register contents acts as a effective address. Okay. The BX register contents acts as a effective address. With that effective address, again physical address can be calculated. Once physical address is calculated, the memory location can be identified. Once memory location is identified, then whatever the data available in that memory location, that data is transferred to AL. Okay. For example, now, for example, BX register is having uh, 3812 hexa, for example. Okay. So now this is the effective address for us. Effective address for us. Okay. And assume that the data segment register is having same, for example, 4500 hexa. This is the data segment register. That means it is the segment base. Already I told you so many times, this is the segment base address. Segment base address. Okay. Now, how to calculate the physical address? Physical address is equal to segment base, segment base, uh, segment base into 10 hexa star 10 hexa plus effective address. What is effective address? 3812 hexa. Okay. That means 4500 into 0. Sorry. 45. Now it's becomes 45000 plus 3812. Okay. So here this is the 2, this is 1, this is 8, this is 8, this is 4. This is now 5 bit. It is a 5 bit, 5 digit. 5 digit means it is a 20 bit. It is a 20 bit, 20 bit physical address. It is a 20 bit physical address. With this 20 bit physical address, microprocessor identifies one memory location. In this particular memory location, for example, 75 data is available because in each memory location, 1 byte of data is available. Okay. So then 75 hexa. This 75 hexa, this number is transferred to AL register. This number is transferred to AL register. Okay. This one here. This number is transferred to, now AL becomes 75. Okay. Here the register indirect addressing mode means the effective address is available in the register, not directly. Okay. In the previous addressing mode, in the previous direct addressing mode. That means the effective address is directly available in the instruction. Okay. The direct addressing mode means the effective address is directly available in the instruction. With this effective address, physical address can be calculated. Okay. But in this next type, register indirect addressing mode, the effective address, this is the effective address. Okay. Effective address is available in one of the register. Effective address is available in one of the register. It is not directly mentioned in the instruction. That's why it is called as the register indirect addressing mode. Okay. Next one is the relative based addressing mode. Relative based addressing mode. Next one is the here relative indexed addressing mode. These are very simple. Relative indexed addressing mode. Okay. Relative based addressing mode is one type. Relative indexed addressing mode is one type. Okay. So here, for example, what is the here? For this addressing mode, we can use either BX or base pointer register. For this indexed addressing mode, relative indexed addressing mode, indexed, okay, that means indexed registers. Either source index registers or destination index registers can be used. For this addressing mode. This is either BX register or base pointer registers. Registers can be used. This is can be used. What is the instruction? Move AL comma, okay, BX for example. Here relative based. Based means either BX or BP, base pointer, but relative, that means it is also having some 8-bit or 16-bit displacement. Okay. For example, here 27 hexa here like this. This is the syntax of this addressing mode. Okay. What is this? Now the effective address can be calculated as, effective address can be calculated as, can be calculated as BX register contents, BX register contents plus 27. Okay. These two is effective address. With that effective address, physical address can be calculated. And once the physical address can be calculated, memory location is identified. Once memory location identified, then the data can be transferred to AL. Okay, here the effective address can be calculated as the sum of BX register contents plus the mentioned specified displacement value. This displacement can be this displacement can be this displacement can be either 8-bit or 16-bit. Either 8-bit or 16-bit number. Okay. Similarly, relative index addressing as same like that. Okay. Here in this BX or BP can be used. Here either SI or DI can be used. Okay. For example, move AL comma SI 28 hexa. Okay. Here the sum of the source index register contents and displacement is the effective address. So here the effective address is equal to source index register contents plus displacement 28 hexa displacement. Okay. So once this is the effective address. Effective address with this effective address. So with this effective address, physical address can be calculated. Physical address will be calculated. Okay. Physical address will be calculated. With the physical address, memory location is identified. Memory location is identified. Memory location is identified. Okay. Once memory location identified, what happens? The relative index addressing mode. Okay. Next one is the relative based indexed addressing mode. Okay. Relative based indexed addressing mode with relative. Okay. So that is move AL comma here BX SI 28 hexa. Now this is the instruction format. Okay. Now in this instruction, this is the effective address. This is the effective address. Okay. That means effective address can be calculated as the sum of BX register contents plus SI register contents plus 28 hexa. With this effective address, okay, with effective address, physical address can be calculated. Physical address can be calculated and physical address memory location is identified. Okay. Okay, sir. Thank you.